If you were to ask a room full of people whether 0.9 repeating is equal to 1, you would likely get a lot of hesitant no's. It feels intuitively wrong. Even if you've seen the proof before, there is a nagging sensation in the back of your mind that says 0.999, going on forever, must be just a tiny bit smaller than 1. It feels like it's forever approaching 1, reaching out for it, but never quite touching it. But what if that intuition is actually a misunderstanding of what numbers are and how we write them down? Let's start with an argument that most of us encounter in middle school. We can all agree that 1/3 is equal to 0.333 repeating forever. If we take that equation and multiply both sides by 3, something strange happens. On the left, 3 times 1/3 is exactly 1. On the right, 3 times 0.3 repeating is 0.9 repeating. If the first statement was true, the conclusion must be true as well. 1 equals 0.9 repeating. Now, you might feel like that's a bit of a cheap trick, perhaps a flaw in how we handle fractions. So let's try a different approach using basic algebra. Let's call our repeating decimal x. So x equals 0.999, and so on. Now, let's multiply both sides by 10. 10x would then be 9.999. Here is the clever part. If we subtract our original x from this new 10x, the infinite string of 9s after the decimal point matches up perfectly. They cancel each other out entirely. 10x minus x is 9x. And 9.9 repeating minus 0.9 repeating is exactly 9. So we are left with the equation 9x equals 9. When we divide both sides by 9, we find that x equals 1. At this point, you might still be skeptical. It feels like we are just manipulating symbols to force a result that doesn't make sense. You might feel like there should be some infinitesimal gap between the two, a tiny microscopic distance that prevents them from being truly the same. But think about what it means for two numbers to be different. If two numbers are truly distinct points on a number line, there must be some space between them. In fact, for any two different real numbers, you should be able to find another number that sits right in the middle, the average of the two. So what is the average of 0.9 repeating and 1? If you try to find a number that is larger than 0.9 repeating but smaller than 1, you'll find that it's impossible to describe. Any 9 you try to change to separate them just results in a number that is already part of the infinite sequence. If there is no space between them, they cannot be two different numbers. This leads us to a deeper realization about how we write math. We often confuse the name of a number with the value of the number itself. The symbol 1 is a name for a specific quantity. The decimal 0.9 repeating is just another name for that exact same quantity. It's no different than saying 1/2 and 2/4 are different names for the same value. To see this formally, we have to look at what a decimal actually represents. When we write 0.999, what we are really writing is a sum. It's 9/10 plus 9/100 plus 9/1000 plus 9/10,000, and so on forever. This is what mathematicians call a geometric series. There is a beautiful, standard formula for the sum of an infinite geometric series. The first term, a, divided by the quantity 1 minus r, where r is the ratio between the terms. In our case, the first term is 9/10, and the ratio is 1/10. If we plug those into the formula, we get 9/10 divided by the quantity 1 minus 1/10. That simplifies to 9/10 divided by 9/10, and anything divided by itself is exactly 1. What this reveals is that an infinite decimal isn't a process that is happening over time. We aren't adding 9s forever. Instead, the decimal represents the limit of that sum. The limit isn't almost 1. The limit is by definition precisely 1. This might still feel uncomfortable because we are used to decimals being unique. We like to think that every point on the number line has one and only one decimal representation. But the real numbers are more flexible than that. The fact that 1 equals 0.9 repeating isn't a bug or a paradox. It's a profound reminder that our system for writing down numbers is just a language. And in the language of decimals, some points on the line are so important that they deserve more than one way to be spoken. Once you let go of the idea that 0.9 repeating is trying to get to 1 and accept that it is already there, the number line starts to look a lot more complete.